Today's webinar is entitled Hitching IT to the TOC Wagon, presented by John Ricketts, author of Achieving the Goal, and it will be facilitated by Philip Maris. All business and government entities today are affected by, if not dependent on, information technology. Some enterprises have a digital constraint because their IT limits the products and services they deliver. However, even when IT is just a support function, it may range from an occasional to a persistent bottleneck. This webinar discusses factors that lead to misalignment between technical strategy and business strategy. It then covers steps that managers can bring to business and technology into alignment. This is a live webinar, 2 hours in length. It will be followed by questions and discussions. Dr. John Ricketts capped his career as a distinguished engineer, chief technology officer, and corporate strategist. John is the author of a chapter of the TOC Handbook, as well as Reaching the Goal. As a path for further learning from today's presentation, we do recommend that you check out John's latest book, Exceeding the Goal. Today's session will be facilitated by Philip Maris. During the presentation, we ask you to type your questions into the question box. They will be answered at the end of the program. For your convenience, a copy of the presentation slides can be found in the handouts of your dashboard. Without further delay, it is my great pleasure to hand this off to John and Philip. Gentlemen, the audience is yours.
Thank you very much. I'm very excited to be invited to interview or to facilitate this for John. When his book came out, I immediately, well, I knew it was coming out. I've been in contact with John for a long time, and I read it. And as soon as I'd started reading it, I knew this was a gold mine, and I posted about it. And simultaneously, I found that the TOCICO was doing the webinar, so we hooked up. John and I, well, it goes back to, for me, Reaching the Goal 2009. Which was a very important and for me fascinating book at the time, because the theory of constraints was a lot more active elsewhere than in services. And so this was and still is today the Bible in terms of applying the theory of constraints to professional services, right? And perchance, we met in Luxembourg in 2011. John was giving a keynote presentation and I was doing one of the obscure, less interesting ones in a corner. But we met in the corridors and stuff, and we hooked up then, and we've been in contact ever since. That's why I knew he was working on this book and very impatient for it to come out. And when it came out, it completely exceeded my expectations. I was thinking it was going to be a follow-up on the subject of reaching the goal to professional services and stuff. But he's been a lot more ambitious than that, and the result is fascinating, I find. It really is a book that has a lot of brilliant stuff in it, so I highly recommend you buy it. It's important because it's aiming at something which is maybe a weak spot today in the theory of constraints, which is the digital world, IT, the whole IT galaxy, which John is going to describe, right? It's quite a complex thing with mainframes, with smartphones and whatever. It's a multi-format thing. Obviously the theory of constraints to be live and healthy today has to work out what the relationship is between this IT thing and the theory of constraints, and John addresses that subject completely, and I find brilliantly. As he wanted, it does exactly what he was trying to do, which is it's both interesting for IT people who want to understand the theory of constraints, and it's interesting for theory of constraints people who want to better understand IT. And I can say, you know, knowing a little bit about the theory of constraints, I'm learning a lot about IT, which some of it I guessed, but John can talk about it with extreme authority, because he hesitates about the reputation of his ex-employer now that he's retired, a thing called International Business Machines, also known as IBM, with its 350,000 people and stuff. And I guess that's because maybe to the common mortal, that's not a very well-known name, but I think in business to business, anybody who's been around in operations of any form these past 30 years. We know that IBM is still a very impressive force and very present in a lot of absolutely critical areas, right? It's just that. So he doesn't say so much that he's been in this rather important company for a long time, and so he knows more than, well, 1,000 times more than I do about IT. So it's fascinating just to see him doing it. So that book, buy it. That's the easy part. Read it. That's the difficult part. I've done a speeding reading, but there's just so many pearls of wisdom, nearly every page, that it's the kind of book you want to read and reread and come back to chapter and chapter. It's really good, even on stuff which I thought, it would bore me to tears, when John explains what the theory of constraints is, and he always has this refreshing, his personal views, his personal ways and words to express it. So even when he's just explaining what the theory of constraints is, or the different types of constraints, it's fascinating. Anyway, I'll shut up, but John did say, if you manage to type in the questions box, right, the right question at the right time, he will field them direct, right? So don't hesitate. I'm watching the questions being typed in, and if the right question comes up at the right time, John is very happy, more than happy, to interrupt and answer the questions as they come. Okay, so off we go, John. It's all over to you.
Right. Thank you, Jennifer, and thank you, Philip. Welcome everybody who's chosen to join us for today's webinar. As they've mentioned, I've spent a lot of time in IT. Also spent about 20 years thinking about TOC in various contexts, and I'm delighted to share with you today some thoughts that I've had along the way. This webinar today, though, is not about standard TOC. I presume that most people on this call have some level of understanding, so I'm going to really focus much more on its application in the realm of information technology. I think I'd like to begin today by talking about an assignment that I had up until the point when I retired. I worked in corporate strategy after having worked in other divisions delivering services and creating software and so forth. My stint in corporate strategy gave me a different perspective because the team that I was a part of had as its mission strategy execution. And that's different from the way many strategic planning departments work in corporations. They spend a lot of time planning, and then they hand off the execution of an initiative to various other departments within the organization. But we, as part of the strategy organization, had the mission to actually go out and execute these strategic initiatives. Bear with me, I got a little technical glitch here I'm working through. All right, let me begin with a little story. The book that Philip mentioned is actually filled with stories. There's about 60 of them. I found that in addition to a description that's sort of along the lines of a tutorial, it was also helpful to include some personal anecdotes, some stories that I chose to call adventures because some of them represent successes and some of them represent failures. So it's a mix of celebration and cautionary tales. The one that I'd like to mention first is an adventure in constraint management, IT, and technical strategy. And it's one where the company that I worked for had an analytics product, software that ran on PCs. It was a mature product. It could do analytics across a variety of data sources, but due to the limitations of PCs, it wasn't really a big data analytics product. And so when the number of data sources and the diversity of data sources and the size of data sources tiptoed into big data realm, it was a challenge for users of that particular product. In fact, we had a competitor that was claiming that their product could handle 10 times as much data as ours. So the strategy execution team swung into motion. We did a proof of concept in 90 days that showed that we could actually scale our product up to 100 times its previous capacity. That proved that the product was capable. Subsequent to the proof of concept, we then scaled it up to over 1,000 times its original capability. And the way we did that was by adding additional horsepower, additional hardware and software on the back end. large servers in effect that could do the data crunching and then provide the data back to the PC, which had a richer set of display capabilities in the form of graphics and charts and so forth. So it was a happy marriage between personal computing and enterprise level computing. And it exceeded the goal because we'd set out in the POC to demonstrate that the capacity could be increased, and in fact, we increased it far beyond the original objective of that POC. So we've already used the abbreviations IT several times on this call, and that's reasonable because I think we all carry around in our mind our own definition of what information technology is. But what I find is that sometimes people have a narrower view than I do. So if you're thinking that IT provides PCs and desk side support, that's true, that's part of IT, but it's a long ways away from the full scope that I'm going to be talking about. So when I say IT, I'm talking about the full range of hardware, all the way from POCs and personal computing up to enterprise level. I also include networks because getting things from point A to point B is an important part of IT. I include all kinds of software, all kinds of services. So when I say IT, think broadly. Eventually in this webinar, we're going to be talking about some things that you can do to manage IT better. And those things align pretty well with TOC principles. Before we get there, however, there's some terminology that I'd like to introduce or at least refresh your mind on because it'll be helpful in understanding the points that come later. So let's talk about a few IT trends that are currently affecting technical strategy in organizations. Here you see a 4-cell matrix. We've got enterprise computing as row number 1, personal computing as row number 2, and then the 2 columns are traditional and cloud computing. By enterprise computing, I'm including both centralized IT, that is the IT that's owned and managed by a CIO and or a CTO, a chief information officer or a chief technology officer. In addition to that, however, I include shadow information technology, which is owned by business units. You've probably seen in your own experience that when business units can't get what they want from central IT, there may be no barriers to them going out and acquiring their own hardware and software and running it on their own. I'm including that in what I consider to be IT. Of course, personal computing includes PCs as well as wearables and tablets. But in today's world, we're into a new realm. Cloud computing is still, I think, legitimately considered a technical innovation. And what's happening at the enterprise level is things that used to require enterprises to buy their own hardware and software can now be handled via as-a-service alternatives that range from infrastructure as a service, which is basically like renting virtual machines, all the way up to an entire business process as a service. Human resources, for instance, is a fairly common business process that's outsourced and performed as a service by an external entity nowadays. So let's contrast that with what's happening in the personal computer realm with regard to cloud computing. Yes, we have smartphones. Yes, we have mobile apps, but the social media, the personal assistants, the smart homes more and more make use of cloud behind the scenes. So connectivity has never been more important than it is today. So with that terminology in place, let me just acknowledge that there's some polarization taking place between enterprise computing and personal computing. The hardware and the software required for enterprise computing tend to be of a scale far beyond what we would associate with personal computing. In a similar vein, there is a migration underway from traditional technologies to this thing called cloud computing. And I'll show you some examples of cloud computing in a moment. What it does is it changes the game. You know, it changes where the constraint in the IT organization may be, and therefore it has the power to change where the constraint in the enterprise is. Now, when I say enterprise, I mean businesses, of course, but I have chosen to use that word enterprise as opposed to just business because there's nothing in what I'm saying that wouldn't be equally applicable to nonprofit organizations and to government organizations. So enterprise is my attempt to capture all of the aforementioned kinds of organizations. Continuing on with this preview of some IT concepts and terminology, IT obviously consumes investment and operating expense, but depending on the specifics of the IT under examination, it may or may not generate revenue. For example, a considerable amount of IT in many organizations simply enables the core business. And an example that I like to use there is payroll. Payroll doesn't generate any revenue, and yet it's an essential function within enterprises. So we have a spectrum of alternatives here that at the other end of the spectrum include IT is the business. You know, as we said at the outset, I used to work for an IT company, and the revenue there was direct from the IT. But between those two poles of this continuum, there's the possibility for IT as an adjunct business. For instance, a manufacturer nowadays may manufacture physical products just as they always have, but they may offer an app to go with those physical products, and that app may be a supplemental or a separate source of revenue. And then, of course, there's IT that's actually embedded in products and services. So when a customer buys the product, some portion of the revenue that's generated by that product actually accounts for the IT that's been embedded in the product and or the service. So before we leave this page, let me just acknowledge that the specifics of IT within a given organization can range from it's a differentiator to it's a barrier to entry, or it's just a commodity and everybody uses the same technology. Something else to keep in mind is that systems can serve various business purposes. If you hear me speak of systems of record, I'm talking about those systems that gather and maintain information, oftentimes stored in large databases. So your customer master record file would be here. Your product master record file would be in a system of record. If you've been in business for any sort of duration, those systems of record have probably been around for a while, and they're probably based on traditional computing technology. Little by little, though, organizations are figuring out ways to take their systems of record and put them into the cloud. Systems of insight include those that take data and turn it into actual information. So if you have an optimization program, that's an example of a systems of insight. If you're participating in some form of social networking, that's a system of engagement. And then last on this list is a system of innovation, which that category of systems reinvents processes, products, services. So if you've introduced TOC applications into your organization, what you were doing was implementing a system of innovation. The reason for talking about these kinds of systems is later on when we talk about how systems get built and maintained, the techniques that are suitable for a system of record may not be as equally suitable for a system of engagement and vice versa. Which then takes us to this question. You've probably asked this question yourself, and I know you've heard other people ask it. Why, oh why is IT a perpetual bottleneck? And my answer is, it's a perpetual bottleneck only if we let it be. There are techniques that can be used to manage IT in a way so that it has enough capacity that it's not the enterprise constraint. Now, within the IT function itself, there may be constraints, but when you look at the enterprise level, as you do when you come from a strategy perspective, as I do, IT doesn't have to be a perpetual bottleneck. So this is a setup for the items that I mentioned a while ago. You know, here are some ways that we can manage IT better. This is not an exhaustive list. It's a list that I put together for today's discussion to stimulate thought. So I hope that you find it useful, and I think you're going to find that there's a rich set of alternatives being presented here. So let's start with number one, recognizing information constraints. You know, the history of TOC is such that we put a lot of emphasis on physical constraints, and for good reason. You know, when you go into a factory and you look at manufacturing, oftentimes it's machines that are the constraint. Although In organizations that have figured that out, more and more what we're finding is that constraint is in areas that may be appear ancillary, such as quality assurance. The same thing happens if you look at distribution. You know, we're concerned with moving physical items from point A to point B. Back when I wrote Reaching the Goal, that pushed TOC into the realm of services, labor-based services to be specific. As we proceed through the rest of this webinar, you hear me talking about technology-based services. Those services that can be either partially or sometimes fully automated using IT. Well, you know, obviously embedded software problems can arise during manufacturing, during distribution. They can also arise after customers have adopted your product or your service. So, you know, software is not a physical constraint. I realize software gets created by people, and people might be considered the physical constraint. Actually, their skills could be the constraint, but it's not always the case that we can trace the constraint to something physical. That's the point here. We're in a world that's being dematerialized. More and more assets are of a non-material nature, and I think it helps us who practice constraint management to recognize that as we're looking for constraints within a local system or indeed within an enterprise, we should be open-minded enough to recognize that software and other forms of non-material, non-corporeal items can ultimately be the constraint. Next on my list here is recognition that legacy systems, the older systems, can contain business rules that are no longer appropriate. And so by legacy systems, think of something that's been running in production for a long time. I'll give you another definition of legacy systems in a little while, but for now, that definition should suffice. Clearly, if the business rules are inappropriate, they're not embodying constraint management thinking, then doing something to fix those legacy systems may be quite appropriate, and I'll have more to say about that in a little while. If you're in a business where the product or the service is digital, then that digital content can be your constraint. There are a number of streaming video services that have emerged in recent years, and far as I know, all of them are dealing with content constraints, to the point that instead of trying to license content from other providers, more and more of these streaming video services are creating their own content because it's their constraint. It's how they're growing their business. And then last on this list is recognition that in the technology realm, in the IT realm, patents are an important form of protection for intellectual property. And if you have a patent, it preserves your own freedom of action. Of course, the converse to that is if somebody else has a patent and it involves a process or a product or a technique that you would like to use, you may be precluded from using it because they have the ability to stop you from using their invention if they have a patent on it. What happens in the IT world, though, is oftentimes company A will have a portfolio of patents, company B will have a portfolio of patents, and rather than enriching the lawyers suing each other, what they will do is they will reach an agreement, a cross-licensing agreement that permits them to use each other's patents unencumbered. So information constraints may be a new concept, food for thought. Second thing that you can consider when you're thinking about ways to manage IT differently than you might have historically is to use the capability that cloud computing provides. In the little story that I opened this webinar with, we initially did what's called scale up. We went from a small machine to a big machine, a small database to a big database. But once we had done that and achieved a 100-fold improvement in performance, then we did what's called scaling out. We added more servers to the hardware of the same kind that we had originally. We added more disk drives to expand the space for databases, so we scaled out. Cloud computing allows that to be done, however, automatically, meaning there are software programs that run that look at the load that's being placed on the system, and they will start new machines, new virtual machines that can serve the additional traffic and scale out automatically and in real time. That's especially helpful for variable workloads, and retail is sort of the poster child for variable workload. Black Friday, the Christmas season, and so forth. If you have to buy hardware and software and size it to meet peak demand, then obviously you've got excess capacity the rest of the year. With cloud computing, however, you can set up your systems so that they scale up when you need, or scale out when you need, and then scale back when you don't need it. I'm not going to talk very much about throughput accounting, but you can imagine that this has a positive effect on your investment as well as your operating expense. But I need to issue a caveat here in that architecture, by architecture I mean the high-level design for born on cloud systems, is just different. And the best way that I know to illustrate the difference is to remind you of some architectures from past eras. If you remember the mainframe era, we tended to write large monolithic systems, and they would access a file or two or a database. And architecturally, they were relatively simple compared to what we see today. When mini computers came along, other architectures found their way into use. The one that's being illustrated here is a pipeline, where you have a program that outputs a file, that file gets read into another program, which produces another file, and so on down the line. A little more complicated in terms of the interfaces, but each one of those programs could be simpler than a monolithic program. So the complexity was beginning to move around. And that movement of complexity continued during the client-server era. By client in this context, what we mean is a personal computer or a similar device connecting over some sort of network to a server, which would then manage the data. That may be familiar if you've tiptoed around IT for a few years. Now let me show you a picture on the right that is a simplified view of what happens in cloud computing. When you hear people talking about microservices and containers and partitioning, those are all terms that have to do with cloud computing. And one of the good things about cloud is each one of the boxes on the right where you see an M, that's meant to represent a microservice. Those software programs may be very simple, but the connection among them may be very complicated. So the complexity has recently moved out of the individual modules and into the interrelationship among those modules. Some of those services may actually be provided by another cloud or another partition within the cloud that you've chosen to do your implementation in. It may actually be provided by a third party. So a third party provision of software is becoming much more common. And it creates an interesting dilemma for enterprise computing, because if you've got a mission critical application that relies on somebody else's software, what happens if that software goes down or the provider decides no longer to support it? There's a fairly well-known case from about 3 years ago where a fellow had written a very simple program, and it was so elegant in its construction and its behavior that it was very widely adopted. And for reasons that are beyond the scope of what we're going to talk about today, he withdrew that software from service, and it immediately brought down hundreds of other companies' applications that depended on it. Took a few days for some enterprising person to recreate that software and solve the problem, but it just illustrates that it was a vulnerability that comes along with all the advantages that cloud computing brings today. Which takes us to number 3. Today you've probably heard about Agile as a methodology. So let me just flash up here the definition of what I mean by an IT methodology, and then show you a couple pictures to contrast a plain methodology with an Agile methodology. If you've been around TOC for a while, you'll recognize that the plain methodology that you see at the top here is actually a simplified critical chain project plan. I say that because you can see on the far right the project buffer, and on the left, in about the middle, there's a feeding buffer. That's just one example of a plain methodology. There are hundreds of commercially available methodologies that fall into this category. Likewise, there are at least 60 variations on an Agile methodology. But as you probably are aware, the Agile methodology was invented for software, and it was intended to overcome some of the perceived shortcomings of planned methodologies. There's a term for a specific format of a planned methodology called the waterfall methodology. So named because when you look at the sequence of tasks in the project plan, it looks like you're moving down a waterfall or a cascade of steps. The chief problem with a waterfall methodology is integration and testing of all these disparate parts that come together to form a system tends to occur late in the methodology. And to the degree that testing uncovers problems, you may have to go way upstream in the methodology to begin to implement a correction to those problems. Now, I need to hasten to say that there's nothing inherent in these planned methodologies that says you have to wait until the end to do integration and testing. Some of the commercially available methodologies are much more iterative than waterfall would imply. All that being said, they're not nearly as iterative as Agile methods. A very popular type of Agile methodology involves 2-week sprints, where something is being delivered every 2 weeks. And that forces the integration and the testing to occur much more frequently than it would with a planned methodology. Agile is a hot topic. It's controversial, though, even within the Agile community. There are some people that are very happy and they're strong advocates. There are other people that are critical of what Agile has become because it has evolved beyond the vision of the founders. But it is still widely used and it's worth knowing about. I view myself as being methodology agnostic. What I mean by that is no methodology is suitable for our projects, and you need to consider a lot of the factors that could affect the likelihood of success. You need to think about the goal, the users, the developer, the platform, the tools, and that may lead you to choose one methodology over another. For example, nowadays, there are legacy systems that run in production every day that were originally written decades ago. They're very large, they're very complex, but they have very high performance and high reliability because they're mission critical. You know, think banking applications or credit card applications. Those need to be really rock solid. And the size of the staff that maintains those systems can be dozens of people. It's not unheard of to have 50 or 60 people maintaining a system of that scale. And they do releases on perhaps a quarterly basis, maybe more frequently, maybe less, but clearly not every 2 weeks. And to try to maintain that kind of system with an Agile methodology is in some ways a misuse of Agile. So one of the things that Agile does very, very well is it helps surface requirements early, and it helps distill the most important requirements and separate them from the perhaps less insignificant requirements. It's been said that Agile is an effective implementation of the 80-20 rule in the sense that 20% of the requirements for a system oftentimes account for 80% of the value. And if you can front load the construction of that key 20%, it may be the case that you never get to all of the other 80% because that initial 20%, that minimum viable product, is sufficient. On the other hand, there's another version of the 80-20 rule in a larger context than just an individual project. The 80-20 rule that I just mentioned for Agile concerns an individual project, but if you look at a portfolio of projects, and there may be hundreds or even thousands of these in a large enterprise, what you may find is that 80% of the budget is for existing systems and only 20% is for the development of new systems. So how you manage that 80% at a portfolio level gets to be a little bit of a different problem than how you use Agile on an individual project. Later on in this webinar, we'll talk about portfolio management. And in fact, I've got an example to show you later on. But for now, it's important to understand that Agile was invented for software where the nature of the system is such that Agile is a good fit. I don't know of a better alternative, but just be aware that not all IT projects fit Agile. For example, building a new data center, you wouldn't want to do that with an Agile method because you might have electricians there before the foundation's laid, or you might have plumbing being done out of order. You know, the sequence of events for doing something like building a data center or doing a large migration from one computing platform to another, those don't work so well with Agile method. They work better with a planned method. So if you've ever wondered whether critical chain has a role to play in IT, I'm giving an enthusiastic thumbs up. I believe it does under the right circumstances. So I've talked a little bit about legacy systems as well as modern systems just now being developed. There's this phenomenon called two-speed IT, which means if there's a system of record that was built as a traditional system, it's large, it's complex, it's being managed with a planned methodology and quarterly releases. The business may have need for a system of engagement or system of insight that draws from that data that's maintained by the system of record. And it may be quite appropriate to have an Agile method, you know, develop those systems of insight and systems of engagement. So it's not the case that it's all or nothing. For a given application, under the right circumstance, you can pick or choose either planned or Agile method. And what that means is that sometimes organizations find that they have two-speed IT. The legacy stuff is slow, the Agile stuff is fast, and there are tools, however, that can help bridge that gap and reduce the disparity between the speed of those two approaches to dealing with systems. Which takes me to point number 4. Point number 4 in terms of managing your IT better is to know where your frontiers are. So let me take you through this graph. Obviously, we've got scope on the vertical and schedule on the horizontal. So you can think of schedule in terms of how long it takes to deliver some functionality, and scope is the amount of functionality. How many reports are there? How many screens are there? How big is the database, and so forth. The dots in the middle of this chart represent projects. The open dots are active projects. The closed green dots represent completed projects. And if you have the right data, you can begin to speculate that there's the minimum viable product frontier. That's how long it takes us to reach minimum viable product status for different size scopes. And you might notice that it's not linear. In fact, if you squint at this, you'll notice that there's a cluster at the lower left, which represents small projects. Then there's a cluster in the middle that represents medium projects, and then the one at the top, large projects. And the slope of these frontiers, and I've now included a fully viable product frontier that creates an envelope between it and the minimum viable product frontier. The slope of those lines goes from greater than 1 for small projects to about 1 for medium projects to less than 1 for large projects, just because the size and complexity diminishes productivity. So if you have this kind of insight into your work in the past, it allows you to ask interesting questions about proposed projects. I just brought up project number 1 here. And if we do a projection of the proposed project 1 onto the MVP frontier, we can make a couple of inferences here. For one thing, it's outside the envelope, and that in itself should stimulate some conversation. It should cause inquiring minds to wonder what's different about that project. Because, well, what this says is that the proposed project would achieve a certain amount of scope, but take twice as long to do it. Or if we consume the full schedule that's being proposed, we could expect perhaps 40% more scope than what is being proposed here. So it looks like there's some padding that's gone on when this project was being proposed. The estimates are maybe guesstimates. It could be that the person proposing this project really didn't have much history and they've simply made an error in their proposal. Or it could be that there's a new team or a new technology that is a tool for building systems, or a new technical platform that means we need to be cautious in our proposal here, because we may not be as productive as we would be if we were dealing with familiar technology, familiar skills. But the point is, if you know where the envelope is, you can ask questions. Here's another example. Project number 2 is outside the envelope in the other direction. And once again, if we do a projection, we can see here what's being proposed is to do more work in less time than anybody has ever done before in this organization, which it's colored red because that ought to be a red flag. It's not to say that that couldn't happen. You know, organizations can do and should approve stretch projects, you know, ones that essentially move the boundaries, the frontiers in their envelope out by demonstrating, you know, some new productivity enhancing capability. On the other hand, if it's pretty far outside the frontier, it's worth, you know, having a serious conversation about whether the estimates are really correct or not. Which leads me then to proposal number 3, which is to take more time than any project has ever taken before and produce less. What's up with that? Are users really going to wait longer for that amount of functionality? Probably not. So consider project number 4. It says we're going to do more in terms of scope than we've ever done before, and we're going to do it in half the time. That should raise red flags. It's probably not going to be a successful project. 3 and 4 are what I would call stretch projects. Number 5, though, I would put clearly in the fantasy project arena. And most large organizations have a system that, or a project that, whose name shall not be mentioned because it was so far outside the envelope that from day one it was probably ill-fated. So what I've been trying to describe is that this envelope informs technical decisions. Doesn't mean that the iron triangle of project management isn't real. It's very, very real. But this is a way to initiate a conversation about that trade-off between having something be better, faster, or cheaper. That's the triangle that I'm referring to. One observation that I'll share with you is that IT oftentimes is pressed for speed when in fact what the users really want is predictability. If there's a key marketing campaign that's going to start in 6 months, or a key product introduction that's going to start in 6 months, users may put pressure on IT to deliver corresponding systems in 90 days. When in fact, if IT had the ability to make a credible estimate and have high confidence that their estimate was achievable, they might be able to commit to a 5-month project as opposed to a 3-month project. And that difference in duration of a project changes the nature of the project. The architecture could be different, the cost profile could be different, the skills involved could be different. So just be aware that if you're in the IT world and the users are asking you for speed, you might want to think about whether what they really want is predictability, because that changes the equation. Which then takes me to guesstimates. I'm a big proponent of using metrics, because that's, in my mind, what distinguishes software engineering from just it being craft work. If you have metrics, then you don't have to do guesstimates. You can do legitimate estimates and show where a proposed project is relative to your productivity envelope. But one of the worst possible outcomes I've seen is to do back scheduling from due dates. You know, a project is launched and customers find that the schedule is slipping, but they want to hold to the original due date. And so a project manager compresses all of the tasks in the project plan, which means if the project was pretty aggressive to begin with, it may be moved into impossible territory by this back scheduling. So please don't do that. And as I illustrated on the previous slide, stretch and fantasy projects are easier to spot if you've got the envelope. But the envelope also gives rise to questions about what could we do to shift the envelope? Could we implement some new training that would make our people more productive? Could we get a new tool that would automate some tasks that are currently being done manually? And if you can do that, it shifts the envelope up and to the left.
John, we have a question. Can you hear me?
Yes, go ahead.
We've got a live question going back to slide 13, where you have scope and budget, scope and schedule. Could you give a little bit more of details of how you measure scope?
Good question. In an agile world, you would probably measure scope with user stories. It's not the only way to do it, but it is one way. In legacy systems, years ago, there was a method invented called function points, which involves counting things like the number of screens, the number of reports, the number of files, and so forth. There's also a much despised metric, but one that is still used, called lines of code. So the point that I'm trying to make with these three disparate alternative ways of measuring scope is that the way that scope is measured for your organization may be different from the way it's measured in other organizations, but there are each of the three methods that I've just mentioned have been widely used in the past. Does that answer the question?
Yes, you have a yes.
All right, thank you. Keep those questions coming, I appreciate them. So I think we were gonna talk about modernizing legacy systems. I promised you earlier that I was gonna give you a second definition of what a legacy system is, and here it is. It's true that a legacy system is one that's based on any previous generation of technology. So systems that were built pre-cloud can be considered legacy systems. On the other hand, a much more aggressive definition of a legacy system is anything that's running in production. So this definition draws the line between development and production. And by that definition, a cloud system that was created last year and went into production last year can be legitimately considered a legacy system. And that's not really unfair or far-fetched when you consider that when systems transition into production, the nature of the problems that have to be overcome are somewhat different. Yes, you still get change requests that would modify the functionality that's built into the system, but you also get bug reports, things that users find that are incorrect and that need to be corrected. You may also find a whole new class of defects. One definition of a defect in a system is failure to implement requirements. But what if the requirements themselves are defective or missing? When you get into production, you may find that second class of requirement defects in that there just was no requirement for this particular thing that the system is supposed to do, and you discovered it once it went into production. So let's talk about modernizing legacy systems. Principal reason to modernize legacy systems is they accumulate what's called technical debt. And technical debt is the price that's paid later for something done today. If there's a change request and it's implemented very rapidly and somewhat casually, the probability that the implementation will contain bugs that either produce misinformation or produce an outage during production is pretty high. So that's a simple example of what I mean by technical debt. Technical debt exists all the way from how the code gets written, all the way up to that high-level design that I called architecture. It can be the case that the original architecture for a system constrains what it can do today. And if it was built to support a business that has changed, then the architecture of the system may need to change. For instance, it might be the case that in the beginning you were a vendor of products like farm equipment. And over the years, what's happened is you've instrumented that farm equipment with embedded software that phones home with data, that phones home with diagnostic messages that say there's a component on the tractor or the combine that's failing, and it ought to be replaced before it requires the unit to be taken out of service. Well, the systems that were put in place decades ago for selling and manufacturing tractors probably didn't take into account embedded software and the data coming back from literally the field. So that's an example of technical debt, and modernizing a legacy system can minimize the technical debt, and in so doing, improve the functionality, improve the reliability, improve the performance. All right, let's move on to number 6 then. This is one of my favorites. Requirements ought to move the needle. And by move the needle, I'm taking a constraint management perspective on things. Ideally, requirements improve the performance of your constraint in your enterprise. I acknowledge that there are local constraints. If you go talk to the CFO, he or she is going to say that cash is probably their constraint. Is cash the constraint for the enterprise? Can be, probably isn't. So requirements, though, should come as close to helping with constraint management as possible. The first bullet that sub-bullet that I've uncovered here is it's not users' responsibility to keep IT busy. That may seem like an odd thing to say, but it's really a callback to what I was saying earlier about Agile being a very viable methodology. When Agile is first introduced, what tends to happen is the people doing the development prior to that were the constraint. They limited the functionality that could be produced. But then when the Agile method is brought in, it allows the developers to produce more in less time, accelerating the delivery, in effect, and accelerating the flow of functionality. And what that means is that the constraint on that project may move back to the users, in the sense that the developers are waiting on the users to tell them what the requirements are so that they can implement those requirements in the next 2-week sprint. Well, my take on that is it's not really users' responsibility to keep IT busy. And if you get yourself into that situation where the developers are running ahead of where the users are in terms of providing requirements, what you're going to find is you're going to get low value requirements. Users are going to start telling you things that you could do that would make their life more convenient and easier, but that have no effect whatsoever on constraint management. So a caveat here is if you get into a situation where the well of requirements is beginning to run dry, that may be a sign that you ought to redeploy some or all of those developers onto something that's going to really provide benefit to the business and not have them create nice to have stuff. Because the more they implement, the more complex systems become, and complexity is the enemy of productivity, compatibility, performance, on down the line. Simpler is always better when it comes to IT implementation, but not too simple. Another insight that I need to share with you or remind you of is that the vast majority of software is seldom or never used. Now, it's fair to say that some of that seldom usage is legitimate. You know, there may be software programs that only run at quarter end to do quarter close of the books, or that only run annually to do the annual report. Yeah, I get that. But setting those aside, if you look at the functionality of software, what you oftentimes find is that there are lots of functions that aren't used, and you can probably relate to that through your own personal experience. You know, if you've used any Office suite, think about how many of the functions you use in that Office suite versus the plethora that are out there in the ribbon or the menu, things that you probably have never used because you don't know what they do. Same thing happens with business-oriented software. Users come up with requirements that are nice to haves as opposed to must-haves, and as a consequence, they wind up never used. So my advice is if you can distill those low-value requirements out early, then you're making more effective use of the investment dollars that you have. The last point on this slide is that, and I go into a fair amount of detail on this in the book, I find it helpful to think in terms of enterprises being systems of systems. You know, there's a financial system, there's a marketing system, there's a sales system, there's a production system, and then there's the IT group. And the reason that I find it helpful to think in terms of systems is if you get engaged to help resolve a problem in any one of those systems, there's going to be a local constraint in that local system. So executives and managers have no problem envisioning constraints within their local systems, but most of those local system constraints aren't the enterprise constraint. And so I find it helpful to think in terms of what's the real enterprise constraint and give any work on constraint management there priority over work on any of the local system constraints. So that takes me back to what's the best way to make sure that the requirements really move the needle. Which takes me then to point number 7 out of 8. When I'm asked to enter an organization and help them identify constraints so as to begin to do better constraint management, if the organization is an IT organization, skills are what I always look at first. It's certainly not the only place that there can be a constraint in the IT organization, but it's my default go-to. And as you know, if you've looked at reaching the goal, when we first implemented constraint management for labor-based services, we did it by establishing skill buffers. And commodity skills were available on short notice, so they didn't need a buffer. Core skills are available with significant lead time, so they definitely need a buffer. And then critical skills, which are chronically in short supply, we would buffer if we could find enough people to put into the buffer. But by definition, since they're critical skills, they're not very plentiful in the job market. And much as we would like to have a buffer, we typically put those people to work the day they arrive. So that's a callback to reaching the goal on labor-based skills. You may have heard that there's a vast difference in productivity amongst developers. And you may be tempted to try to go out and hire people who are 10 times more productive as anybody else. I need to put the brakes on that notion because yes, there are differences in capability amongst programmers and developers, but a 3x difference in productivity between neophytes and the most senior technical people is a little more realistic. So I oftentimes counsel clients to not swing for the fences in terms of trying to hire all stars, but swing for finding people who are good technical leaders. Technical leadership trumps individual performance in many, many cases. So last point that I'll make is when it comes to skills, IT tends to be fairly tribal. You know, there are people who like the agile method and they don't really want to do anything else. There are people who like to do operations, and for them, the plain methodology is just fine. Where you can get into trouble is hiring people who are very conservative in their view and put them onto a team where the existing team membership is very liberal in terms of their attitude about how you build systems. All right, which takes us to number 8, and this one is going to take some time to walk through. What I've suggested earlier in my remarks is that IT investment is valuable. In fact, it's essential nowadays, but no enterprise that I'm aware of has an unlimited budget. So there are always trade-offs to be considered. And I think constraint management really makes a contribution here. If you think of managing IT not as a set of separate projects, but instead as a portfolio from which you must pick and choose and make good decisions. That's what I mean when I talk about portfolio management. Now, in TOC land, throughput accounting has been around since Ellie was around. More recently, Ellie Schragenheim and Mr. Camp have published a book on information economics or throughput economics, which is an update on some familiar concepts and an extension. They talk about how to make comparisons between alternatives. And I describe that in exceeding the goal as doing delta analysis. Delta is the Greek symbol for difference, and I highly recommend looking at information economics and familiarizing yourself with how to do delta analysis. I'm not going to be able to do a quantitative example here, but I'll hint at delta analysis as I get into the example momentarily. Something else that I advocate is thinking about strategic horizons. And I have a slide that I'm going to show you in a moment. In fact, if you've got the PDF and you want to skip ahead a slide, that's fine. But for now, let me just park the idea of strategic horizons. We'll come back to that momentarily. I've already talked about focusing on the enterprise constraint first and foremost. I've talked about not optimizing non-constraints. It's so easy to spend IT investment dollars optimizing non-constraints that I think that's a point worth emphasizing. I've talked about setting priorities and letting the low priorities expire. And of course, managing work in process is vital. That's one thing that Agile does very well, is it tends to minimize the work in process compared to a planned project, but minimizing work in process isn't the only consideration. Which takes me to strategic horizons. This is actually a model that came from a book published by consultants some years ago. I've augmented it a little bit, but it's fundamentally their idea. And you interpret it this way. The curve that's labeled H1, that's Horizon 1, that's your current business, the products and services you are selling today. Horizon 2 extends from a year or two from now out to maybe 5 years. Or if you're in a high-tech industry, it may extend from next quarter out to the end of your next fiscal year. The actual length of these horizons depends on the pace of your industry. But in manufacturing, it's fairly common to think of Horizon 2 as being from 2 to 5 years out. It's the next wave of products. It's the next model of Chevrolet. It's the next model of tractor. The ones that are having to be engineered now and for which you're doing tooling so that your manufacturing will be able to make the new models. And of course, if there's embedded software, then you got to have the software engineers working on that. Which takes me to H3, Horizon 3. That's the stuff going on beyond year 5, possibly out to year 10 or even beyond. That's your idea generation laboratory. That's where your R&D people are saying, instead of doing gasoline-powered or diesel-powered vehicles, let's do electric vehicles. Can we build an electric combine? I don't know. Let's see. Let's do some R&D on that, and then maybe we can do a proof of concept to see if farmers will even buy it. That's what we mean by H3. The reason that I'm laying out these strategic horizons from an enterprise perspective is if your IT plans, if your IT strategy isn't aligned with your business strategy, you may find yourself with a tractor that is set up for electric power and not have the right software to manage it. One more point about strategic horizons before we move on is there's an H0 here. That was not in the original model. I added it though because there are products and services that companies keep around because they're necessary for customer retention. So if somebody bought a John Deere tractor 20 years ago, it's probably still in operation today and they jolly well want to buy parts for it. So H0 is an example of products and services or parts to support them that aren't necessarily today's business. They may not even be profitable, but you need to have them in the mix so that you retain customers for the future. Which takes us then to some portfolio management considerations. Some of these we've seen, and we literally just saw the horizons consideration. We've talked about platforms, traditional versus cloud. We haven't talked about artificial intelligence or machine language. That's sort of beyond the scope of what we could do within the time constraints today, but be aware that there's more than just the two types of platforms. We talked about systems of record, insight, engagement, and innovation. We talked about methods, priorities, risk, ROI. You can plug in there what you might glean from throughput accounting, throughput economics. We haven't talked about the life cycle of applications or of products based on them, but I think if you look through the stages of a life cycle here, that you will find them familiar. And what I'm headed toward is a table that we're going to see on the next page that's a very simplified view of a hypothetical information technology portfolio. It has 12 rows representing 12 systems, and you're going to see that each one of those rows has these attributes. So you'll see how many we have in research, how many in development, how many are in maintenance, and so forth. And then last, what we'll eventually work our way around to is the decision. You know, what's the status based on what we have decided during portfolio management? We'll see projects that are proposed, some that are approved, some that are throttled, and so on down the list. Which takes us then to page 21. I encourage you to stick with page 21 for a moment and not flip ahead to page 22. You know, we'll do a reveal on that in a moment. The reason for that is I'd like for you to look at some attributes here before we get into the throughput accounting, throughput economics view. To help you understand what you're looking at here, and by the way, if you have the PDF and can use that, you might find it easier to see than the small print on the screen. Unfortunately, even though this is a very small example, I couldn't use large font type. So if you have the PDF, follow along there. If you don't have it, that's fine. I'm going to try to talk you through the details here. So you can just close your eyes and listen. The leftmost column here is the ID column for these various systems under consideration. OPS stands for information technology that's supporting operations of this manufacturing firm. DIS is for distribution, MKT is for marketing. CIO and CTO are the Chief Information Officer, the Chief Technology Officer, respectively. So if you let your eyes wander over the other columns, let me suggest that these are the impressions you take away. There's a fair number of systems that are in maintenance. There's a fair number of systems of record. A fair number that are being managed with planned methodology, which is not to say that there aren't systems in development. There aren't systems of engagement or innovation. There are some systems that are being done agile. And there's a potpourri of platforms. But when you get over to the horizons column, you can see there's a lot of emphasis on Horizon 1, a little bit on Horizon 2, a little bit on Horizon 3, but not a lot. So from a portfolio management perspective, maybe, you know, the strategist ought to be talking with the people in R&D about how they could propose more projects for Horizon 3 opportunities, knowing that you're going to be generating ideas in Horizon 3 that don't make it into Horizon 2. And by the same token, you may have some things that you do in Horizon 2 that don't make it into Horizon 1, but you have to feed the pipeline, not only for the business, but then you have to talk to the IT guys so that they are doing their work in concert with what you're expecting to do for the business. So if I do another reveal here, we can see two more columns representing risk and priority. Quite a diverse set of risks. And likewise, some priorities. Interestingly, the highest priority system has the highest risk, and it's in the operations arena. That, in fact, turns out to be the system that's allied with the enterprise constraint. This system does scheduling, it handles inventory, so it's how you manage work in process. It's basically the embodiment of TOC for this particular manufacturer. So if it's down, the business is down. That's why it's high risk and why enhancements to it are very high priority. So let's drop down to the opposite end of the spectrum in a sense. The CTO, the person in that role, him or her, is thinking about proofs of concept that could be done or research that should be done that could eventually lead to a proof of concept. Those tend to be fairly low risk projects. You know, you're not driving your business with them. Yeah, you're making some investment, but it's not going to be the end of the world if a proof of concept doesn't pan out. And so there's kind of an assortment of priorities associated with those opportunities. It looks like CTO1, which is the third from the bottom, is a proposal for a proof of concept for a system of insight using the Agile method, and it would use artificial intelligence or machine language or machine learning, perhaps to glean some insights into maintainability of the products. Going back to the tractor analogy, if there are readings coming off of gauges that would indicate a problem, maybe a bearing is going to go bad, machine learning could identify those signals and have a new bearing shipped to the farmer even before the old bearing fails. So it's low priority, low risk, but it is a Horizon 2 opportunity, and so it's worthy of consideration, even though it's not the highest priority out there. Which then takes me to this reveal. For those of you that are not following along, but are just listening to my voice, what I've revealed is a fairly large table that has some data from a throughput accounting, throughput economics perspective. And without burying into the details here, the main takeaway that I'm trying to have you glean from this example is, if all you had was the throughput accounting information, it might lead you to a different conclusion than if you had looked at the previous attributes of these projects. Because some of these IT projects are investment only or operating expense only. They don't generate any revenue themselves, but they're necessary because, well, one of them was involved a settlement to a lawsuit. It might have had something to do with labor relations, and this system keeps track of hours and skills and new hires and attrition and retirement and so forth. And it doesn't contribute anything to revenue for the organization, but it's mandatory that you do it because it was part of a settlement. Likewise, there may be systems out here that for regulatory reasons or legal reasons, you have to do tax reporting. So you have to have an accounting system to do that. It's not going to show up as a moneymaker in throughput accounting, but it's necessary to run the business. Also in here for some of the more forward-looking alternatives, the Horizon 2 and 3 projects, there are some that have the potential for generating revenue for the organization, and so that's factored into the table at the bottom. So let me cut to the chase here and reveal the final column. It's in the table at the top. It says status, and what you can see here is the first couple of systems are active. They're in production. There's one that's been frozen. There's one that's been approved but hasn't been launched yet. A couple more that are active. There's another one that's throttled because it's waiting on skills to become available from the project that's being terminated. They're going to go off of the terminated project and over onto the one that's throttled, but timing matters, and so forth. Which takes me to the end of those remarks. Let me just make a couple comments here, and then we'll open it up for general Q&A. The reason that I chose the title Exceeding the Goal for the book is back when I was doing strategic initiatives, strategy execution, we had as a goal for that part of the business to have 50% of our proofs of concept succeed, where succeed was defined as not that the technology worked, because the technology worked in 100% of the cases. It was whether the business owners that we were doing the POC for saw enough value in what we were proposing that they would buy it, literally buy it. We would go from proof of concept status into startup status and then into scale up status. So the little story that I started with at the beginning, where we had a PC product that we scaled out and scaled up, that particular piece of software was subsequently used in several different industries. It started off being used in financial services, but it eventually was used in intelligence operations, in military operations. It was used in a NATO exercise because what they had was so many sources of information that were uncorrelated that their tacticians, their battlefield tacticians, couldn't make sense of all the data they were receiving. So an important attribute of the big data analysis was filtering and separating out what was important from what was unimportant. And that takes me back to the program that I was a part of. We actually succeeded in over 80% of the cases. And I tell you, there's no better feeling than being able to set a goal and then exceed it. Which takes us to the question of how do you exceed the goal? And my answer is you combine constraint management with information technology and have a good, sensible technical strategy. With that then, if you'd like to contact me subsequently, I'm on LinkedIn. I also respond to email, and feel free to reach out. So with that, I'm going to hand it back to Philip to see what questions we might have.
Thanks, John. Thank you. And yeah, here's the book. And as I say, the easy part is to buy it, but do more than that. Read it. I found it absolutely fascinating, right from the first page, and it's unputdownable and extraordinary. Even as I say, for people who even understand both subjects of IT and theory of constraints, I'm certainly interested in what's been written about the theory of constraints in there. Okay, while we're waiting for the other questions to come in, John, can I just go back to something we discussed as we were preparing this webinar, which I found fascinating, which is if one does find that IT is the constraint of the organization, right, the usual what I call the matryoshka doll phenomena. It's not IT that's the constraint, it's something within IT. So in more detail, what kind of constraints do you find within IT? What do you mean by a constraint in IT? And that, what was for me, maybe obvious, I don't know, but a surprising one, which was often the constraints in that kind of thing are the new skills or the new technology, the stuff that you haven't yet acquired in sufficient quantity. But in IT, there's a special twist, which is that the old skills can become the constraint. I'm talking, of course, about the COBOL programmer.
Mm-hmm. Yeah, the way I've described that problem is oftentimes the leading edge moves quickly and the trailing edge doesn't move at all. So over time, the portfolio becomes more and more complex. You've got these old legacy systems that, unfortunately, the term legacy system sounds like it's pejorative, and I don't mean it that way at all. These are valuable systems. They're running the business. But because they are old, they've grown large and complex, and they may be difficult to maintain to the point that they have programs within them that are so difficult to change that nobody wants to touch them for fear that they will cause a production outage. And when you're into those kinds of circumstances, it's helpful to modernize the system, not only to get rid of the defects, but also to maybe move the technology along so that it's easier to find skills that can cope with it. You know, entry-level COBOL programmers have a different skill set than career COBOL programmers. And there are programs nowadays that are out there to generate the next generation, so to speak, of legacy systems maintainers, but it's not glamorous work. And so one of the phenomena that has been going on for 30 years now is outsourcing of some of those technologies that are hard to hire for domestically. You know, by that I mean in the United States and Europe, a fair amount of the maintenance work is moving to lower cost countries, and some of the IT providers in those countries have identified those legacy skills as being a niche that they can work themselves into.
Okay, thanks. And some of the other kinds of constraints in IT that you could find, you mentioned stuff like architecture testing and stuff in our discussion.
Yeah. When I was a CTO in a software organization, the most precious skill that we had was IT architect. They're in that, you remember when I talked about 3 kinds of skill groups? There's one where you'd like to have a buffer, but you can't because the skills are so precious and hard to find. IT architect is a preeminent example in the IT world of somebody that fits into that skill group. We actually had a career path that would take people who had expressed interest in that career path and take them step by step so that they got classroom learning and they got learning on the job and they got mentored by other people. So IT architect is a precious skill. I should also mention that at one point in my career, I managed an organization that was staffed with Top Gun project managers. And they actually introduced critical chain into our IT business. They, though, spent a fair amount of their time going out and rescuing projects that had gotten themselves into trouble through some of the pitfalls that I mentioned earlier, back scheduling from an arbitrary due date, not paying enough attention to architecture early on, and therefore having to use a guesstimate rather than a fact-based or an empirical kind of estimate. So my team of Top Gun project managers would go out and help figure out how to rescue those projects. But what they put together was a list of top 10 pitfalls that it's the same list that we compiled 20 years ago. You still find people falling into today. And we use that to try to become more proactive and get out ahead of problems. So we would do education sessions. And I think a lot of that education actually wound up working its way into the certification program for project managers. So that's another key skill.
Okay, thank you. We have a question from Tel Aviv about how do you manage business teams when the IT organization can't deliver all the demand. Let me just try and go live with that one. Tal, if you're there, I see you're there. I'm going to put your microphone on. Maybe you could repeat the question you've typed in.
Sure. My question is, and I think that's the big problem, is the IT organization is basically can't keep up with current demand, but the business team keep on demanding new features, new projects, new capabilities. So they see the IT organization as a bottleneck to or constraint for any kind of business growth, while the IT team itself is already dealing with all the demands that previously were delivered. So how do you avoid that? How do you build the pipeline to get the right demands to the top of the line?
I would point you to the 5 focusing steps in TOC. Exploiting the constraint, subordinating other things to it, and so forth. And what that translates into in IT terms, setting aside the TOC speak for the moment, is if your business is really that robust, it's really generating enough revenue that you can afford to funnel more investment into the IT realm, you simply increase your IT capacity to try to better accommodate the demands being placed on it. That's not to say that you can't employ some of the other techniques that I've already mentioned previously. Cutting back on the things that are low value investments is the best way that I know of to refunnel and direct your precious investment and skills into the things that really do matter. So what I hope one of the main takeaways from this session is that with portfolio management, according to the method that I've mentioned to you here, it gives you the ability to say no to a lot of stuff that at the end of the day doesn't matter. It just doesn't move the needle. So if you push back on the users to demonstrate how $1,000 investment in IT is going to generate more than that in terms of revenue, that's a useful conversation to have. Thanks for your
Okay,
question, by the way.
thank you. How about the big classic question, and have John Ricketts' answer to: when should you use critical chain? When should you use agile? Or when should you mix them?
Oh, another great question. Well, Agile was invented to help discover requirements early and to filter the most important requirements from the less important ones. So if you have a project that basically fits those criteria and there's some urgency associated with it, that tips it into the Agile category. If, on the other hand, you have a project that is large, complex, and for which the requirements are pretty unambiguous, it tips that toward the planned methodology end of the scale. And let me give you an example of how it can go wrong. I need to reiterate that I am methodology agnostic. I believe that both camps have methodologies that are appropriate under the right circumstances. But let me give an example of where I believe the wrong choice was made. It was an organization that was suffering the two-speed IT problem. Their quarterly releases from their system of record were okay, but they desperately needed a system of engagement, and they needed it to be much more nimble than that. You know, new functionality all the time to keep people engaged. Unfortunately, the system of engagement needed to get its data from the system of record. So what this organization attempted to do was force the Agile method into the maintenance of the system of record. And it was a problem because with Agile, ideally what you do is daily builds. And that's IT speak for you take all the components that comprise the system and you run a program that puts them all together so that they will actually run in a test environment. And you can make sure that things work and work correctly. And you do that on a daily basis. Well, with a large legacy system, it may take more than a day just to do the build. And then it may take several days to do the test after you've done the build. So there's this disparity in timeline between what can physically be accomplished and what the Agile method demands. So one of the ways that they began to attack that problem was, instead of using Agile method on the main system, they carved off interfaces between the main system and what could be built Agile-wise for a system of engagement. So it was a hybrid at that point, both in terms of their technical platform and in terms of their methodology. That was the right thing to do. Where they went wrong, though, was they attempted to improve the productivity of the main maintenance team by equipping them with new tools that would make them more Agile-like. So here again, a laudable objective. They wanted to take the large complex system, make it more Agile with tools. But that required migration from the old to the new. And that migration was going to be done by people who had done it before. They were highly experienced. They had their own method. It was a planned method. It wasn't critical chain, but it could have been critical chain. The requirements were absolutely unambiguous. They knew exactly what they needed to do. And because they had experience, they could estimate how long it was going to take them to do it. Now, you'd think with those criteria, it might have been a slam dunk to say, do it, and do it as fast as you can. No. This organization insisted that they adopt Agile method. And so the people who knew how to do the conversion process wound up in multiple stand-up meetings every day, because this company had put multiple project managers onto this Agile project trying to get it to go faster. And it was a complete impedance mismatch. In the end, it took about 3 times as long to do the project as it would have done, as it would have taken if they had just let the team do what they already knew how to do. So I cite that as an unfortunate example of some malpractice. If you have the simple criteria right, you can pick and choose and get a pretty good match between methodology and what the intended desire is.
Okay.
Great question.
Thank you. You might want another sip of coffee. We have a visibly a slow starting group. They've just started hammering out lots of pretty deep and long questions. So take a deep breath. They're piling in now, and there's some big ones. Again, what I'll try and do to make sure.
Can I interfere if I?
Yeah, sure. Yeah, Ellie, go ahead. I recognize the voice, right? Ellie Schragenheim, right?
Thank you. Yes, John. First of all, it was really a great webinar. But I'd like you to put your mind what should be the relationship between general management, those who produce the flow of requirements to the IT, and the management of the IT department themselves. And also, please refer also to your very nice H1, H2, and H3, and what should be the role of developing strategy together. Strategy for a product or not IT, but might need IT or even take the new capabilities of IT to bring it to something really new technology, and what can be done with it.
Okay, well, I think there's actually several questions in there, and let me see if I can address all of them. Regarding the relationship between IT management and business management, it's probably going to be no surprise when I say I think it ought to be a closer working relationship. Some organizations have undertaken to foster that closer relationship actually by changing the skill mix of people in key leadership positions. For example, it used to be, and by used to be, I'm saying maybe 15 years ago, the chief information officer position was highly technical. So naturally, the person in that position, you know, was snowproof on the technology, but maybe not as proficient in terms of their understanding of the business. Nowadays, it's much more common to find someone in the CIO position who actually comes from the business. And he or she admittedly has to have some level of technical understanding, but they can surround themselves with technical experts who are on call to provide additional insights as needed to inform the CIO and close the gap on the technology side, knowing that the CIO, by virtue of coming from the business side, they've already got that level of understanding. The one caveat I would issue in situations like that, though, is it's easy for a non-technical CIO to fall in love with fantasy projects. That's the single biggest risk that I see there. So to the degree that you have an engineering-minded organization and the technical experts that are advising this non-technical CIO can whisper in his or her ear, you avoid that pitfall. Now, another aspect to answering this question is let me refer all the way back to one of the early slides I had where I talked about central IT versus shadow IT. Mm-hmm. Some organizations have solved this dilemma of how to bridge the gap between IT and the business by just letting the businesses develop their own IT. They own it, they run it, they're responsible for it, so they can make sensible investment decisions. But what it means is you lose some economy of scale and you lose some inconsistency or some consistency between business entities. So to the degree that when you look at the information flows through the organization, if there's a lot of crossing subsystem boundaries, then having shadow IT can be a problem. On the other hand, there are plenty of opportunities for reasonable shadow IT to be successful. And as an example of that, let me cite turnkey systems. A turnkey system is one where you buy the hardware or the software, or more and more nowadays you acquire something that's out on the cloud, but it's the equivalent of buying hardware and software, and it just works. You know, you can do that with pay systems now. You can do that with merchandising systems, with advertising. And in those kind of cases, the ownership of the IT resides out in the businesses, but they don't have to staff up and have their own IT staff quite to the same level that they would have if they were doing everything homegrown. So central versus shadow there's some tension there, but it can work just fine having some of each. Now, I think the third part of your question had to do with setting strategy. And yes. Best advice I can offer there is to make sure that the IT strategists and the business strategists sit down in the same room from time to time and ask themselves, where are we aligned and where are we misaligned? It could be, for instance, that they're misaligned in terms of horizons. If the business is very forward thinking and they're already, deeply into Horizon 3 and IT is still struggling with Horizon 1, eventually they're going to run out of runway. So an early heads up would be, we need to get more IT that's H2 and H3 oriented and less focus on H1. The other thing that can happen when you get the strategy teams together is you can do more experimentation. I'm a strong believer in proofs of concept, having done that for years, and having seen what went before. So I've been around long enough that I can remember when emerging business opportunities involved a 5-year plan, and then that evolved down to 2-year plans and 1-year plans. And when we were doing proofs of concept, we were doing them for 90 days. Some of them went beyond 90 days, but the initial results were within 90 days. And in the spirit of doing things rapidly, at the front end of a proof of concept, you have to make a decision through the lens of a venture capitalist. So I actually wore the venture capitalist hat during those discussions, and we would do calculations like we saw in the portfolio management example I went through, and we would look at criteria such as the tables that I had in the portfolio management session. And then we would put together a project plan, and what I just described sounds like it's fairly ponderous, but from the point in time when we had a completed proposal until we made a decision was 48 hours, start to finish on the decision. And then we would kick off the POC, and 90 days later we're done. And what's great about that is it's essentially agile for strategy. Everything we've talked about so far has been agile for system development. But if you take that same mindset and you step away from being a programmer and you put on your strategist hat, how great is it to be able to go test some ideas out and find out, well, it worked or it didn't work, and we only spent 10,000 instead of 100,000 to get the answer. So hopefully that gets at all aspects of your question, Ellie.
Yes, I think so. I just like to pose a kind of an example. Like suddenly in the manufacturing world, there is the slogan of Industry 4.0, which from my outside perspective looks like a huge promise, which sometimes is true and most of the time is probably fantasy. How on the upper level, when an idea comes, here we have a technology. Okay, the technology is already there. What can we do with it in order to go into our at least H2 kind of a strategy? What kind of relationship, what kind of new knowledge both the IT and the management need to have to consider seriously such kind of an idea?
Well, let me acknowledge at the outset that I am far from an expert on Factory 4.0, but what I do know about it looks to be an evolution of things that have gone before. It's, there have been networks in manufacturing operations for decades, but what's different nowadays is the software and the data collection and the sources of the data. Within IT nowadays, we talk about the Internet of Things to distinguish it from the Internet of people and processes that went before. When the Internet was new, so was email, and and we were at a very rudimentary state in terms of connecting things together. But nowadays, you know, refrigerators in homes have sensors in them. So we've evolved to smart homes that can raise an alert if something's gone wrong with the refrigerator or the furnace or whatever. The same kind of technology is being employed in factory settings, but it's being deployed in context with robots and the like. And what I haven't seen yet, and I guess I'm going to have to throw part of the answer to this question back to Philip. What I haven't seen yet is a deep understanding of things you can do with the new data. You know, is machine learning a part of 4.0, and how mature is the machine learning technology? Because you know, if you look at the growth of robots nowadays, the growth of robots exceeds the growth of employment in manufacturing. And I got to wonder if machine learning might make the robots even more effective than they are today. So let me bring Philip in on this one. You know more about Factory 4.0 than I do. Philip, you out there?
Yeah, but it's your webinar, John. And my short answer is I'm suspicious indeed of having so much more data, because I think many organizations are already not digesting the data that is already available, and having 100 times more is going to make things worse and not better. You know, there are already signals saying that the machine is about to break down. In today's world, they don't need an email or a text message saying that machine is overheating. The guy standing next to it knows there's something wrong with his machine, and he's been saying that there's something wrong with his machine for 3 weeks. So I'm kind of suspicious with that aspect of Industry 4.0. But let me shut up. It's your show.
Well, your answer is a good one. So thank you for chiming in there. I think at the best reaction that I can give is we need to be selective in what we implement and not get overwhelmed by this tsunami of data. But to the degree that we can use that data to better manage work in process, why not?
Okay, Eddie, you want some more questions, or shall I field the written?
No, other questions now.
Okay, Christopher Boyk, you have a long question, so rather than me reading it, can I suggest that you say it in your own words? And unfortunately, there are 2 of you participating. So I'm not quite sure which Christopher Boyk I should type in. So I'm trying to get you in. But as I say, there are 2 of you participating. It's sort of your screen and your phone sort of thing. And Jennifer, can you help me? I can't get Christopher to speak, to open up his mic.
Chris, try to, he's self-muted, so go ahead, Chris.
Chris, can you, otherwise I'll read the question, but it's properly written and all that, but I thought you might want to say it yourself. You've cut your mic, Chris. Are you there? How do we know if he's there? Can you put your hand up, for instance, so that I can read the question? There's not a problem. It's all properly typed in, but I just thought it'd be more fun if you read it. I'll let Chris write something in the chat just to make sure he's still there and all that, because I'm not quite sure.
I'm here.
Yeah. Okay, Chris, I presume you heard what I was saying. Why don't you read out your question or rephrase your question?
At a high level, IT is nothing more than a manufacturing line for the majority of the work that's out there. And as a result, you've got one work center, another work center, another work center, another work center, which all are doing different activities. Now, this could be something like middleware, this could be database, this could be the developers, a number of different items like that. How do you convince the business to restrict the flow of new projects? based on the availability of that bottleneck to be able to implement the 5 focusing steps to ensure that everything is going to be able to move smoothly in the flow of this organization. And so that way the projects are able, and the ongoing operations work, what I call operations work, production work that's already in flight, is able to be maintained.
Okay, thanks for that question, Chris. It sounds like that's a question coming more from an IT provider than from an organization where IT is just a support function. Am I correct in that perception?
No, actually, it would be in an IT support function role. You're typically divided into, you will typically have DBAs, you'll have network folks, you'll have data center operations, you'll have server operations, you'll have, in most large organizations and even medium-sized organizations. So you have a limited amount of capacity in those resources to be able to implement new projects. Granted, you have the capacity constraint at a architect level, as you mentioned before, because they have to ultimately come up with the appropriate solution. But you have the people who actually have to implement these projects, and also the people who are maintaining what's already out there today. And that balance of the flow between the work centers and the capacity constraints. Let's say that you have 3 server engineers, you have 3 database admins, you have 3 network people, yada, 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 in those different areas, but you only have 2 people in the developer role, or you have 2 people in a middleware role or something like that. That becomes the capacity constraint of the workflow as a result.
I think I get it now. What you're describing is almost a classic TOC dilemma, in the sense that you're describing a series of dependent events. You do A and then B and then C and then D and so forth. Before I talk about that, let me just acknowledge, though, that there's some aspects of IT work that are not serial like that. They're a series of, or a set of, interdependent events, and I put software development in that category because what the architect does depends on what the users do, and what the architect does affects what the developers do, and what the developers do affects what the testers do. But if you look at the flow of work, it doesn't just go A, B, C, D, E. It's much more turbulent than that. And in fact, in an agile environment, there may not necessarily be a differentiation of skills. You know, everybody's expected to write code, everybody's expected to manage databases, and so it's even less stratified than you might find in a larger team where there are specialists. You know, there might be front-end specialists and back-end specialists, as you described before. So coming back to your question, how do you manage capacity in that kind of environment? Well, if it's truly an internal constraint, you hire this or train the skills as you need them, recognizing that in some cases there might be lead time issues, but if there aren't lead time issues, then you hire to demand. If there are lead time issues, I'd suggest you look at the replenishment example in Reaching the Goal, because it talks about how to establish skill buffers. So you're hiring in anticipation of demands that may be coming, but you're not hiring too much. You're keeping your capacity in sync with the demand by using a buffer.
Understood, and thank you for that. In a lot of the cases where I'm seeing this type of behavior, it's often where the resources are typically, they are doing a large amount of work together, but they're also segmented and have their specialities. And unfortunately, you run into the chaotic red ocean scenario where every project is basically demanding the resources of these specialists,
Yep.
and they're not controlling the flow of the release of new work based on that. And you do need to have the buffer management in place.
Right. Yeah, if you don't have the ability to say no and throttle projects, then yeah, you tend to get this collision of capacity and finite capacity chasing infinite demand. You know, one thing I would also suggest is in reaching the goal, we talked about multi-project management, and the TOC classic approach is to pick a constraint that affects a series of similar projects, like projects. The classic example being aircraft maintenance. If every aircraft has to go into the hangar, then there might be some steps before it goes in, then some steps that are performed while it's in the hangar, and then some steps post-hangar. So the hangar becomes the constraint in that scenario. And although each individual aircraft's project is separate, they all have a common dependency on that physical constraint. You can do the same thing with IT skills, but the advantage to having a skill buffer is you disconnect the projects. And that disconnecting was really important to us when we were in a technical services arena, because you never really know for sure when a client is going to sign a contract. But as soon as they sign the contract, they want boots on the ground like the next day. So you can't wait until you've got a contract signed to go hire the people that are going to staff that contract. Having a buffer of skills means you can deploy immediately and then replenish the buffer. So I offer that up as another thing to consider. If, for instance, you're short on IT architects or short on testers, put extra emphasis on trying to build buffers for those skill groups. Is there more to your question, Chris?
Thank you very much.
Oh,
Okay.
great question.
Thank you. We have another question from James Berry, and again, if he so wishes, his question is very well written and so forth, but maybe he'd like to repeat it orally, so I'll attempt to open up his microphone, see if he's around. James, I've opened up your microphone. Would you like to repeat your question?
Yeah. Hi, Philip. Hi, John. Thanks very much for the webinar. It's worth getting up at 1 a.m. in the morning for. Yeah, my question is to do with the DevOps movement and how it fits into the the picture that you drew, John, in particular, maybe with the methodologies you talked about, planned versus agile. I guess agile would encompass DevOps. Maybe I'm interested in the background of the DevOps movement and how effectively the book, the Phoenix Project, was a rewrite of the goal with Bill Palmer in the role of Alex Rogo, and how you see the DevOps movement fitting into the future IT.
Well, let me tell you how I handled it in exceeding the goal, and I need to issue a caveat here. Some things that I write in my books are intentionally controversial. It's intended to make people think, and it doesn't bother me if people disagree with some of the things that I say that are controversial. My description of DevOps is not very lengthy in the book, but what I did that's potentially controversial is I lumped it in with Agile. And I know some DevOps devotees would object to that characterization. So let me take a half step back, define what I mean by DevOps, and let's see if we get agreement on the meaning of what it is, and then we can talk more about the implications of it and its relationship to Agile. In my prepared remarks, I didn't talk about DevOps, but the short description is, it used to be that there would be a team that would develop a system, and then there would be a handoff to the operations team, which would run it in production. And to accomplish that handoff, there are what's called environments. Environment is just IT speak for an area of a computing system where you can put the programs and you can run them, but the environments serve different purposes. You know, there's a development environment where the developers can do whatever they want, and when they have their software written to the point that it's ready to progress, they promote it into another environment where perhaps it can be tested, and then that gets promoted into another environment where it's ready for production, but it's not in production yet, and then into another environment for it's in production. And so there's a defined process for getting it from development to production that may involve intermediate steps. The key takeaway from that description, though, is you've got separation of concerns between the people doing the development and the people doing the operations. Sometimes it's been, that transition has been described as throwing it over the wall, because things land in the operations team's lap that maybe they wouldn't have signed up for if they had a choice. DevOps is a solution to that problem in that it puts the responsibility onto the same team, both for development and for operations. And in some ways, it's kind of a brilliant solution, because who better to identify and resolve production problems than the people that wrote the code and did the testing on it. On the other hand, it means that the team never sleeps, right? Because somebody's got to be on call 24/7. And that's a little different from the development environment where, you know, every now and then the caffeine wears off and they go grab a couple hours sleep, but they're not on call 24/7. With DevOps, that integrated responsibility means it never goes away. So to some people's mind, DevOps is the logical extension of Agile. It's Agile for operations, and in addition to the blending. To other people, it's a bit of a different animal. It's an attempt to take the lessons learned from Agile and get more leverage out of them. So let me pause at this point and see, James, do you view Agile, or do you view DevOps, define it the same way I do?
Yeah, I mean, the definition itself is under dispute all the time, right? You know, it seems to be more of a culture than a methodology or a, you know, a certification you can get, you know.
One of the trends that I'm seeing in the DevOps space is much more reliant on monitors and systems that aren't a part of the business system per se, but they run in the cloud environment and they monitor what the business system is doing and its relationship to other systems to make it possible to diagnose where, you know, where something is going wrong. Because if you think back to the slide that I used to illustrate born on cloud architecture, you know, that was an artist's conception. I mean, it was greatly simplified compared to what really gets built out there. So if you picture not, you know, 10 boxes, but hundreds of boxes out there, when transactions start to fail in a DevOps environment, figuring out, was it program A or B or C or D or microservice A, B, C, or D, just finding out which one was the problem is sometimes 9/10 of the battle. So I guess what this rambling answer gets us back to is what I said earlier about the natural state of things in IT is to become ever more complex. And if every now and then you can take a step back and simplify what you've already got, then from that point forward, life gets a bit easier. So thank you for your question, James.
Thank you.
Okay, we have, I think, yeah, one last question. There was a question, but the person unfortunately left before, and I'll forward it to you so you can get in contact with the answer, John. We have one last question from Susan Solomon. Again, if I'll try and see if I can put the mic on so she can repeat it. It's how to deal with difficult conversations.
How to
Susan,
deal with difficult conversations.
it's coming. I'll read the question otherwise. Susan, I think you might have to switch on your microphone. I've tried, I can't. It won't unmute. Jennifer, could you turn on the microphone of Susan Solomon?
It's self-muted, so we'll need to.
Okay, well, I've got a message saying it won't unmute.
He's there now.
Okay, okay. You hit your computer, I guess, right? Because now you unmuted it.
Something.
Susan.
Hi, John. Thanks so much for today. My question relates to Ellie's and Chris's as well, where in an organization where IT is not a revenue generator, trying to have these difficult conversations around throttling projects coming through, or truly trying to be that strategic partner is difficult or can be difficult. Do you have experience in that, and what guidance would you say in trying to change that dynamic from just being an internal service to an actual strategic partner?
Mm-hmm. Well, thank you for that question, Susan. I appreciate it. I'm not going to pretend to have all the answers to this question, but I can give you an answer. And this is from personal experience. We got engaged with an IT organization that was a bit at odds with their user community. And what we helped them do was undertake a performance improvement initiative. It was literally a strategic initiative sanctioned by and funded by the CIO. And what we did was, part of their dilemma was they had 2 data centers. So this example is a few years old, but I think it's still a valid example. They had 2 data centers, and one of their data centers did primarily back-end processing, heavy number crunching and systems of record. And then the other data center did primarily front-end processing, which was systems of engagement, systems of insight, and so forth. But they depended on each other. None of those systems were separate from each other. And yet, because they were physically separate locations, their processes were different. In fact, there's an old saying in the IT world that, as soon as you move people to a different floor or a different building or a different campus or a different country, you've automatically changed the architecture of whatever they build. You can literally see the organization chart in the architecture of the systems that get built. So that was part of the problem here. But another part of the problem was they had inconsistency between their data centers that led to inefficiencies. So we worked with the IT people, we worked with the user people on their role, and we created 2 as-is diagrams of their process at each data center. Then we brought the teams together and we reconciled the as-is process so that we had a single foundation for going forward. And then the 2 teams collaboratively built the future to-be process. And it didn't take them very long to implement some of the changes that we had made, which in turn improved the velocity on the changes from the users. So we didn't quite get to the point where IT was running faster than the users in terms of requirements, but we did enough that it gave them breathing room, and the fact that it was trending in the right direction changed the conversation between the users and the IT people. So at the same time that they did process improvement, they also implemented a metrics program. So we began to collect data that would allow them to look at that envelope and be smarter in what they proposed. So when they were giving an estimate and a bid to their user group, the users could see the reasoning behind it and the data behind it and have more confidence that it was a good estimate. So it was that a bit of maturation in how the organization worked. And after, I think it was about a year, maybe less, their performance had improved 40%, which is, that's double digits. That's certainly significant for IT performance improvement. And it it improved the work life of the people in IT so much that they actually came back to us and asked us to propose another improvement initiative to their CIO. For a lot of reasons, he didn't do that, but it's an example that stands out to me because it's very rarely the case that you've got people coming begging you to do another one of those performance improvement kinds of projects. So it's not an exact answer to your question, but I hope it's sufficient for today, Susan.
Thank you.
Back to you, Philip.
All right, just finding the right buttons. Okay, John, are you up to some more questions? We've been at it 2 hours, 10 minutes, but there's some more questions out here.
Oh, okay. You told me that was the last one, but sure, let's go for it.
Oh, sorry, yeah, got that. Okay, let's make this the last one. Ian Heptinstall, let me do as you try and unmute the mic so you can repeat your question. Sorry?
His microphone's open. He just needs to unmute.
Yeah, Ian, if you unmute your mic, maybe you'd like to repeat your point.
These webinars give you sympathy for all the students and parents doing homeschooling now.
The button's been pressed. It wasn't really a question, it was just an observation.
Yeah.
I'm glad somebody in IT said the same thing, John, which I never really got DevOps because everything I read said it's involving the downstream people who run something in the upstream design engineering of whatever it is. And I never actually realized that projects would not do that. Coming from my environment, it was just the norm. You wouldn't design a car without considering people who drive cars. it just sort of shocked me. Yeah, and presumably it applies whether you're doing agile or planned or whatever. You know, it's about getting the right team together at the right time.
Right. You know, one of the starkest contrasts between project management styles that I've ever seen is the contrast between how the construction industry works and how IT works. Because in construction, you have a project that creates an architecture and design, and you have blueprints, and that project is over. And then you have a construction project that actually builds. It's not the way we do it in IT. We mash those together. So the architecture, the design, the build, the test, and now the operations all get smooshed together. So, like I said, it's no wonder that IT teams run on caffeine.
Yeah, but the other nice analogy, John, since you're talking about the relationship between the construction industry and IT industry, as you point out, it means that in IT, 90% of the houses they build, nobody lives in.
Yeah, well, another quote from years ago is, if programmers built programs the way builders, or if builders built buildings the way programmers write programs, the first woodpecker to come along would destroy civilization.
Okay. Well, thank you for a great webinar. This book, we had a discussion, John and I, to decide, what we were putting into this webinar. It's absolutely impossible to give a summary of the book in a 1 hour, 2 hour, 3 hour, 10 hour format, I think. So we just tried to pick some pieces. Let me just conclude by saying once again, frankly, this book is extraordinary because we're talking about a very, very important subject, IT in its multifaceted, omnipresent form of today. John, with his huge experience of IT, knows all about that, and his theory of constraint expertise and knowledge feeds it and really hits the nail on the head as far as I'm concerned in terms of moving way forward in terms of understanding that cocktail, that interconnection, and how theory constraints could feed IT and IT can feed theory constraints. Okay, so thanks for a fantastic job. Buy the book, buy 3 copies, and so forth. Highly recommended. Okay, and thanks for a great webinar, John.
You're welcome. Good day, everyone.
Bye.
Thank you, John. Thank you, Philip. Just a final farewell and great presentation. Thank you for the engaging dialogue at the end as well. We will end the webinar right now and hope you join us for a future one.